Hello, this is Miss Moore, and today during chemistry we're going to continue discussing the moles. Specifically, we're going to discuss converting from moles to mass. Today's essential question: how is mass calculated from the number of moles? For today's lecture, you need to have your scientific calculator handy and your periodic table. All right, let's do this. Atomic mass. And an element's atomic mass is the number of protons plus the number of neutrons. Hope you guys remember that from way back when. Normally, we use the atomic mass, the average atomic mass, which takes into account the isotopes, and the unit used is AMU. And that's the number on the periodic table. Today we're going to be discussing, instead of the atomic mass, we're going to be discussing the molar mass of an element, or an atom. So the molar mass is the mass of 1 mole of an atom, or 6.022 times 10 to the 23rd atoms of that element. And this is kind of cool. The molar mass of an element is the same number as the element's atomic mass, but has the units grams. So it's the number on the periodic table. It just has the unit grams. So, for example, the atomic mass of carbon is 12.01 AMU. The molar mass of carbon is 12.01 grams. And I got that off the periodic table. All right, next up, molar mass of a molecule. Keep in mind, a molecule is 2 or more atoms joined together, bonded together. Okay, so quick review on chemical formulas. A chemical formula tells you what elements are present in a compound and the number of elements present. So we look at our old standby, water. The chemical formula of water tells us that water is made up of 2 hydrogens and an oxygen. Okay, so to figure out the molar mass of a molecule or of an ionic compound, it's the sum, or adding up, all of the masses of all of the atoms in the formula, and we express that in grams. Okay. So a quick example. The molar mass of KNO3, or potassium nitrate, is found by adding the molar masses of 1 potassium, 1 nitrogen, and 3 oxygens. So I'm going to start by looking at the periodic table and finding the molar mass of each of those atoms. So potassium has a molar mass of 39.10, nitrogen 14.01, and our oxygens all have a molar mass of 16 grams. Okay. From there, we simply add those up and come up with 101.11 grams. Okay, now we need to go back and think about our sig figs. Each one of our measurements has 4 sig figs, right? So that means our answer needs to have 4 sig figs. So we'll keep the 101.1. We'll drop the 1, and because it's less than 5, we just drop it, and our final answer is 101.1 grams. Okay, so that's all you have to do to figure out the molar mass of a molecule. It's actually really easy. You need to be careful though, because it's also really easy to make a mistake. Okay? All right, moles to mass. Quick review. There are how many atoms in a mole? 6.022 times 10 to the 23rd. And how many molecules in a mole? 6.022 times 10 to the 23rd. Okay, how many donuts in a mole? 6.022 times 10 to the 23rd. Okay, so here's the question for today. How much does 1 or many moles of an atom or molecule weigh? Okay, to determine this, we must convert from mass to moles or from moles to mass. And the equation we're going to use, or the equality, or conversion factor, is 1 mole equals molar mass in grams of the element or compound. And this can be written, if you would like, on your unit conversion table. Okay, let's get to the main point of the lecture, which is converting from moles to molar mass. Right? And so our practice problem as we go through the steps will be, what is the mass of 36 mole of potassium nitrate? Okay, so the first thing we want to do is rewrite the problem as a math problem. And we know we have 36 mole of CaNO3 and we're trying to find out what that is in grams. Okay. Okay, next, just like yesterday, set up the grid and write the given or the known over 1. So again, we know we have 36 mole of CaNO3 And step 3, we write out the equality or the conversion factor that relates the units given in the problem. And in the problem, we have moles and grams. So the equality we have is 1 mole equals molar mass in grams. And that means we need to add up the molar masses of let's do it. Molar masses of 1 calcium. So we have calcium. We have, how many nitrogens? This number out here, outside the parentheses, distributes to everything inside the parentheses. So we have 2 nitrogens, and 2 times 3, we have 6 oxygens. So we'll check out the periodic table and find our molar masses. So calcium is 40.08 grams. Our 2 nitrogens are 14.01 grams. And our 6 oxygens are 16.00 grams times 6. Okay, so let's calculate that and see what our molar mass is. And I came up with an answer of 164.1 grams. Looks like we're supposed to have 4 sig figs, which we do. So now our equality, I've got a mess going on here. Let's get rid of some of this stuff. Our equality would then be 1 mole of CaNO3 equals 164.1 grams. CaNO3. In this case, it's really important that you write the molecule because while it's true that 1 mole of CaNO3 equals 164.1 grams, that's not true of everything. It's not true that 1 mole of, let's say, sodium equals 164.1 grams. Okay, so always make sure you put the molecule names in there. Now, we're going to put the conversion factor, our 1 mole of CaNO3 equals 164.1 grams, into the grid, setting it up so that all units cancel out. And since we have moles at the top, we need to put moles at the bottom. So 1 mole CaNO3 at the bottom. And at the top goes 164.1 gram CaNO3. Cross out our units and, in this case, molecules. Make sure we set things up right. And let me make a little more space here. We'll get rid of this part now. Now, just multiply across. And I got 5,907.6 grams CaNO3. And our sig figs in this case, we have 4 here and only 2 here, so our sig figs are going to be 2. So our answer can be 5900 grams CaNO3 and if you're more comfortable with scientific notation, we could have 5.9 times 10 to the 3rd grams CaNO3 2. That's really all there is to it. So next up, let's try it. Alright, so if you could check out the problems, hit pause, try to do at least number 1 on your own, hit play, see how you did, then you can try number 2 on your own. Okay? Alright, so question number 1. How many moles are in 92.2 grams iron 3 oxide? So we'll start with our math problem. 92.2 grams Fe2O3 is what we know, and what we're wondering about is what that is in moles. Okay, so then we'll make our grid and put our known in the grid. Alright, and next is our equality. So we have grams and moles, and the equality that we know that has grams and moles in it is 1 mole of, in this case, Fe2O3 equals the molar mass of Fe2O3. So that means we need to get the molar mass of an iron, an oxygen, an oxygen, and an oxygen. So the molar mass of iron is 55.85 grams. And our oxygens are 16 grams each. So when we add those all up, we get 159.7 grams. Okay, so that means our equality is, let's get rid of this stuff, it's a mess. So now our equality is 1 mole Fe2O3 equals 159.7 grams Fe2O3. Okay, now we got to put these in our grid. And this time I'm going to put the grams on the bottom because grams is already on the top. So you can cross it out, 159.7 grams, Fe2O3. I forgot to talk about sig figs. Well, each of our measurements had 4 sig figs, so we should have 4 sig figs in the answer. Top 1 mole, Fe2O3. Alright, this time we need to multiply across the top, multiply across the bottom. So we get 92.2 mole Fe2O3 over 159.7. And when we divide, I got 0.5777332498 mole Fe2O3. And sig figs. Let's see, we have 3 sig figs here and 4 sig figs here. So we're going to have 3 sig figs, which is the 0.577. 3 is less than 5, so we're just going to drop it. So we're going to end up with 0.577 mole Fe2O3. And if you would prefer scientific notation, we could also write that is 5.77 times 10 to the negative 1 mole Fe2O3. All right, number 2, what is the mass in grams of 3.32 mole potassium carbonate? So let's start with our math problem. 3.32 mole K2CO3 equals X grams K2CO3. Okay. Then we'll write our grid and put our known in the grid. So we have 3.32 mole K2CO3 over 1. And for our quality, we again have mole and grams. So we're going to use the 1 mole equals molar mass in grams of K2CO3. So we need to add up the masses of 2 Ks, a C, and 3 O's. So the molar mass of potassium is 39.10 grams. And the molar mass of carbon is 12.00 grams, and oxygens are 16.00 grams. And when we add those all up, we end up with 138.21 grams. And when we look at sig figs, our measurements all have 4 sig figs. This guy has 5 numbers. So our equality will be, let's get rid of all this stuff so I have room. Our equality will be 1 mole of K2CO3 equals 138.2 grams K2CO3. All right, so when we put this in the grid, I'm going to put the moles on the bottom because we have moles on the top and we want to be able to cross out. So we have 1 mole K2CO3 on the bottom. And on the top, we're going to have 138.2 grams K2CO3. Those cross out. And now we just multiply across and come up with 458.84 grams K2CO3. And let's check our sig figs. So we have here is 3 sig figs. And over here we have 4 sig figs. So we need to have 3 sig figs. Before 58, we're going to be dropping the 8, but being that it's 5 or bigger, we're going to round up. So our final answer will be 459 grams K2CO3. All right, that's it for today.